So we're going to go over Unit 9 and Unit 10. Unit 9 is 3 view drawings and Unit 10 is 2 view drawings. So 3 view drawings is a common practice when developing an engineering drawing is to display an object using front, top, and right side view. These 3 views typically provide all the shape and size detail needed to produce the part. However, there are some instances where the other views may be selected to provide greater clarity. Figure 9.1 shows how a typical 3 view drawing is developed. Figure 9.2 shows how the object would appear on the final drawing. The projection lines show both figures are provided to show how surfaces of the object are projected and alignment of the surface between the views. The miter line of 9.2 demonstrates new view alignment and equal spacing between the views. Projection lines do not appear on a finished drawing and are used here for illustration purposes only. So figure 9.1, projecting the 3 view, and then figure 9.2, a typical 3 view drawing. So you got your front view. The front view of an object is the view that shows the greatest detail of the part. It generally is the view of the object that will provide the most descriptive shape information. It is not necessarily the front of the part as it is used in its actual operation. The top view is located directly over and in line with the front view. It is drawn as if the drafter were standing over the object looking straight down. The right side view is the most common side view used in 3 view drawings. It is drawn to the right and in line of the front view. And then bottom views are not used in standard drawing practice and thus may be considered a special view. Prints with the top, front, and right side views or some combination of these views are most common. Bottom views are used when it is necessary to bring the details not clearly shown in other views. The bottom view should include only those lines that are necessary to complete the description of the object. Figure 9.3, by the same rule, the lines shown in the bottom view may be omitted from the top view. So top and front wouldn't show that it has this arc in the bottom, so that's why you had to put the bottom view on. So partial view is one of which only part of the object is shown. Sufficient information given in a partial view to complete the description of the object. So figure 9.4 illustrates an example of the proper use of a partial view. A break line is provided to show where the view ends. So there's your break line and your partial view. Partial views provide the following advantages. They save drawing time, they conserve space that may otherwise be required to draw an object completely, and they sometimes permit a larger scale view. This allows details to be brought in more clearly. Other views. If an object is even more complex, other views may also be needed. So here's a sketch that you can actually do on your own in the book. And then here would be the actual assignment that we would do. We're going to omit this one and we're just going to do the 2 view drawing on Unit 10, I'm sorry. So Unit 10 is 2 view drawings. 2 view drawings, some complex cylindrical or flat objects may require 2 views to provide full understanding of the part. When 2 views are needed, the drafter must select the views that will best describe the true size and shape of the object in its greatest detail. Usually, combinations of the front and right side or front and top view are used. However, other views such as side view or bottom view may be used as well. The selection is determined by eliminating any unnecessary view. Any unnecessary view is one that repeats the same description in another view. Figures 10.1 and A and B show 2 examples of unnecessary views. So, as you can see, the front and right are identical, so you could do front and top, or you could do the top and front are identical, so front or right, or top or right, whichever way you wanted to do it. So projecting cylindrical work. Cylindrical pieces that may require more than one view include shafts, collars, studs, and bolts. The view chosen for the front shows the length of and shape of the object. The top view or side view describes the object as it might be seen looking at the end. A top or side view of the object shows the circular shape of the part. The cylindrical piece always has a center line through its axes. In the circular view, a small cross indicates the center of the object. Figure 10.2, the dimension of the diameter is generally given in the same view as the length of the object. So, cylindrical object shown in two views, so front view and right side view. And dimensioning cylindrical work, it's going to show your diameter here, your length, and the only reason you would have to have a side view would be that it has a flat on it. So here's your sketch that you can do on your own. That's in the book. And then here is your actual 4.5 assignment. Again, I will go over these next Monday, so don't freak out if it gives you an incorrect answer even though you got it right. Thank y'all.